Okay, so in this video we're going to be looking at lines of symmetry and rotational symmetry within quadrilateral shapes. Now we have a square, a rectangle and a trapezium that we're going to demonstrate this with. Firstly, we're going to look at lines of symmetry. At school, usually you could do this using mirrors. However, here we're going to show you we've cut the shapes out, and what you can do to demonstrate a line of symmetry is fold the shape. And now a shape has a line of symmetry is when you fold it, you can see it folds perfectly without seeing any overlapping bits of paper. So you can see here this rectangle has a line of symmetry down its middle. And of course you can fold it the other way, and it also has a lovely line of symmetry there as well. However, the rectangle does not have a line of symmetry if I fold it diagonally. So if I fold it across the diagonal, we can see that we're getting bits of paper that aren't overlapping perfectly. So the lines of symmetry in a rectangle are as shown. The lines of symmetry in a trapezium, very simple. There's just the one, and it's just straight down the middle across the top. See, folding perfectly like that. Now the square possesses a really unique property, and it has, like the rectangle, a line of symmetry down the middle and a line of symmetry across, which you can fold again, it's there, of course there. But of course, because the square has equal sides, this means these sides are equal, meaning you can fold across the diagonal perfectly as well. The square isn't cut out brilliantly, but you can see that a perfect square would possess lines of symmetry across both of its diagonals. So the square has a nice little star line of symmetry. Now we're going to look at rotational symmetry. Rotational symmetry is when you rotate a shape either 90 or 180 degrees, either clockwise or anti-clockwise, and it still looks the same. To demonstrate this, what we're going to do, we've drawn red lines around the perimeters of the shape, as they now are, and what I'm going to do is I'm going to draw a blue dot in the top left hand corner of each shape, so when we rotate it we can see where that dot's gone. So firstly, let's look at the rectangle. When we rotate the rectangle by 90 degrees, we can see that it overlaps its original red perimeter, meaning it doesn't have rotational symmetry at 90 degrees. However, when we rotate the rectangle 180 degrees, we can see that it does fit into that original red perimeter, meaning a rectangle has 180 degrees of rotational symmetry. With the square, much like the rectangle, we can rotate it 180 degrees and it will fit into that little red perimeter as before. However, with the square we can also rotate it 90 degrees and it will fit in. So the square has both 180 degree and 90 degree rotational symmetry. Now finally, when we look at the trapezium, we see that because of these slanted sides, it makes it very difficult to achieve rotational symmetry, whatever rotation we use. If we rotate it 90 degrees, it's not going to fit whatsoever. And again with 180 degrees, as Mrs. Jones has pointed out, it is going to be upside down.
Pretty pattern.
So a trapezium actually has no rotational symmetry whatsoever. The only way you can achieve the original position is by rotating it 360, but we know that's the same as not rotating it at all. And that's the key thing here, is if you don't rotate it at all, that doesn't mean it has rotational symmetry.
It's just been left here. Okay,
it's just
brilliant.
been left.
Thank you.